Okay, so this video is about correlations for scatter plots. Scatter plots are just like a bunch of dots plotted on a graph, okay? So here we're gonna have strong versus weak positive correlation. So this means it goes up. Now it's strong if the dots are close to form like a straight line. And it's weak if they're kind of wide, all right? So let's look at this. The dots here, they're going up, but they're kind of like wide out. So this would be considered a weak, widely spread out. In this one here, the dots, right, are kind of like close together. So this is considered a weak positive. Sorry, it's considered a weak positive. Hello. These dots are close together, so this is a strong positive correlation. This next one here, the dots are kind of wide on this graph, so this would be a weak positive correlation. This one, I would say these are a little bit more closer together, right? They're not like super spread out on this graph. So I would consider this a strong positive correlation, okay? So notice the difference. See how wide apart these are, and then see how closer together these are. So that's the difference here. Now let's talk about strong and weak negative correlation. So in this one, it's negative obviously if it goes down. And the same type of rules apply, right? If it's close versus if it's kind of wide. So in this first one here, they're going down and they seem to be pretty close on this graph. So I'm gonna say this is a strong negative correlation. This one too, I would say these are pretty close on this graph here. They're not really wide out. So again, I would say this is a strong negative correlation, and it's negative because it's going down. This next one here, these are kind of wide, right? They're pretty spread out. So I would call this a weak negative correlation. Same with this one. It's going down and it's pretty wide looking on this graph. So I would say this is a weak negative correlation. All right, the next one is a no correlation. This kind of looks like fireworks or splatter. It's not really going up, it's not really going down, it's just kind of there. So I would say this is considered a no correlation. So we put no NC or no correlation. This next one also doesn't really go up, doesn't really go down, it's just kind of like fireworks. So I would say this is a no correlation as well. Then we have the line of best fit, right? Basically, it's drawing a line down the middle of the data. Right, so look at this one. Look at how it like cuts kind of that data in half, like it's going through it in the middle. Same here, it's cutting that data in half, kind of going through it, trying to keep it in the middle. Same thing with this one, cutting through that data in half down the middle. Cutting through this data down the middle as best as it can with all of these, but no line of best fit with no correlations, right? You can't draw a line. There's no downward or upward direction that's happening, okay? So there's that. Now, we're gonna get to where we interpret the scatter plots. So we're gonna do some reading and some writing. And Mr. McDonald runs all the golf courses in Illinois and can make a pretty accurate prediction of how long it will take to mow a lawn based on its size. Here are the mow times for some of the golf courses he is in charge of. Now, what type of correlation occurs between mowing time and lawn size? So, is it strong positive, weak positive, strong negative, weak negative? So looking at this graph here, what would you say? I would say this is like a strong positive, personally, right? It's going up And if I put a line here, like it's not really wide, it's pretty close together. So I would say this is a strong positive correlation. Next question. How long does it take to mow a lawn that is 700 square meters? Well, let's see. I got minutes on the side here, and then I got lawn in square meters. So here's 700. I'm gonna go up and see if there's a dot there. And there is. So that time is 210 minutes. Next one here. What size lawn would take 60 minutes to mow? So my minutes is on the side, so I'm gonna find 60. I'm gonna go until I see a dot. All right, and this dot, oh my gosh, I'm not gonna panic. It's in between 300 and 400. So I'm gonna say 350, and I'm gonna say square meters. Now, as the lawn size increases, what happens to mowing time? So as my lawn gets bigger and bigger, what's happening to your mow time? The mow time starts to increase, okay? So reading and interpreting, not that bad. Just be careful with these strong, weak positives, negatives, no correlations, and lines of best fits. That's the end of this video.